Hello, everyone. Welcome to today's exploration of two fascinating types of cells in electrochemistry, the electrochemical cell and the electrolytic cell. Though both involve redox reactions, they have distinct functions, processes, and applications. Let's dive in and compare them. First, let's talk about the electrochemical cell. An electrochemical cell, such as a voltaic or galvanic cell, is a device that converts chemical energy into electrical energy. It operates spontaneously, meaning the chemical reactions inside happen on their own without any external power source. A great example of an electrochemical cell in action is the battery. Whether it's in your phone or a flashlight, these cells are what power many of the devices we use every day. The anode is where oxidation happens, and it's the negative electrode. The cathode, where reduction occurs, is the positive electrode. Electrons naturally flow from the anode to the cathode, generating electricity in the process. In simple terms, an electrochemical cell generates electricity through spontaneous reactions, allowing the electron flow to power devices. Now, let's move on to the electrolytic cell. Unlike the electrochemical cell, an electrolytic cell works in the opposite direction. It converts electrical energy into chemical energy. In an electrolytic cell, an external power source is required to drive a non-spontaneous redox reaction, meaning the reaction won't happen naturally without electricity. This process is used in applications like water electrolysis or metal plating. The anode is still the site of oxidation, but in an electrolytic cell, it's the positive electrode. The cathode, where reduction occurs, is now the negative electrode. In this case, the external power source forces electrons to flow from the cathode to the anode, reversing the usual flow you see in an electrochemical cell. In an electrochemical cell, chemical energy is converted into electrical energy through spontaneous reactions. In an electrolytic cell, electrical energy is converted into chemical energy, and it requires an external power source to drive the non-spontaneous reactions. Thanks for joining me in this exploration of electrochemical and electrolytic cells. I hope you now have a clearer understanding of how they work and their roles in modern technology.